Hello folks, and welcome to your next exciting Tesla Model 3 drive unit hacking update video. Now, as you will see in the course of this episode, there is a reason why the Gome Cat, as you will see here, has turned his back on me. It is not without a sense of shame that he is doing this. Because I done screwed up AA Damien. And yeah, you're going to see just how badly fairly soon. Before that, though, some messages from our sponsors. As usual, this video will be available free from any advertisements or any crap on Vimeo. Should you wish to see it there without someone trying to convince you that gambling is good, you need to subscribe to some, I don't know, whatever it is they try to sell me. They try to sell me so many things that I just forget them. My brain is too full. So anyhow, as I say, if you wish to avoid all that, pop over to Vimeo. I'm just kind of a little speechless here because although I'm shooting the intro to this, I've just literally finished what I was trying to do. So yeah, all right, that's enough of me rambling. Sit back, relax, and Gome, I'm so sorry. Can you ever forgive me, Gome, for being such a Gome? No, he can't. He just shook the head. No chance. Okay, well, here we go. Alrighty, so we're back at our inverter here. And what we're going to be doing in this segment, basically, is putting our TMS 320F 28377D fancy kick-ass TI microcontroller back on here. So before we can do that, the first trick that we need to do is we need to give this a thorough cleaning with some IPA. So I'm getting a little IPA on a rag. I'm just going to give this much of a little bit of a dabbing as I can, just to, we've had a lot of experimentation going on around this area here between little boards and various other experiments that we've tried here. So reverse engineering tasks and everything else in between. So I do want to make sure that we've as little things like flux residues or any of that going on there. So I'm going to just get rid of as much of that as I can. I just got my hot air station set to a very low temperature, just 100 degrees. I'm just going to use that just to evaporate off the IPA from around here. Try and just get rid of any residue there might be. There we go. All right. Now, so the first thing we need to be conscious of when we're putting our device back on here is that these packages have this large center pad on them. Now you'll see here on the board that this center pad is quite extensively via stitched down into one of the intermediate layers, probably a ground plane. In fact, it would be a ground plane. So we have to attach the corresponding bottom pad from the package to this pad here. Now, as you may recall, when we removed this original part, I was putting a lot of heat in here, and even still it wouldn't desolder this until I got the whole package off and then used the low temperature solder to eventually melt it. Now the reason for that is down to this stitching, because it's basically pulling the heat down into a large copper ground plane within the PCB, which is what it's designed to do, because this also, as well as serving as a ground for the device, also serves as a heatsink, because this is a dual core device with lots of transistors in there, so it needs to get the heat out. So if we were to attempt to put our device package back on here by traditional soldering, I think we would fail badly. So we have a little bit of a different plan for you, and we'll see if that's going to work. All right, so the method we're going to be using for attaching that bottom pad is a cold soldering technique. So for those interested, this is a product manufactured by MG Chemicals. It's a two-part epoxy that we are going to use to attach the center pad on our device to the PCB. I'll put a link in the description to this. This is the higher temperature curing version. They do have a room temperature cure version of this. Sadly, the higher temperature cure version was the only one that I could get without having to wait nearly a month or even more to get it. Very expensive little product. What you're looking at here, these two little syringes, were just over €100. But the good news is we only need a tiny amount of this stuff. It's got a nice long 4-hour working time on it, so we shouldn't have any difficulties. So basically we're going to place a quantity of this on the center pad, fix the device back on, solder the pads, and then we will cure this stuff when we have the device on there. Alright, so I'm going to mix a little of our magic potion on here. All kinds of Danger and Will Robinson and stuff on the backs of this, so I'm sure it'll be just fine. Let's see, dispense equal amounts of epoxy, mix together with a mixing stick, and apply. Heat cure at 65 for 2 hours. Okay, we can do that. So let's go for it. This definitely feels like the bomb disposal side of things, you know, where I do one step and see if I blow myself up. And yeah. Okay. I'll pull that back in. So there's one piece. Only need really a little, you know. Probably even got way too much there, to be honest. There we go. Okay. Just going to use a little piece of copper wire here just as the... yeah, that's way too much. Just as the mixing element. Probably end up putting more of it on the bottom of this little tub than I will on the actual PCB. Yeah, I think I've probably blown about 20 euros worth of this stuff on here already. Does not want to mix. Well, it does, but it's just very tacky. I guess that's the silver loading in it. So this is basically, you know, a substitute for high temperature soldering. All right, that looks pretty well, you know, mixed up. I don't think we can do any more than that. I'm going to call that good. Yeah, let's call that good. All right, let's move over to the drive unit. Okay, so here on the drive unit, I'm just going to take my not so efficient mixing stick here, and just a little dab of this stuff, and hopefully just smear it onto, there we go. Just put a little blob of it, really, I think is probably the way to go, because the chip will naturally kind of want to push down on it. Probably needed to have a second piece of this just to, or a second implement to scrape this down. Let's see, yeah, here we go. Temptation here to put on too much of this is really going to be high, I suspect. What could possibly go wrong? Okay, that's definitely enough. So the tiniest little amount of this is definitely where we want to be. Now, so for the next phase of the operation, I want to put some tack flux around the standard pads around the periphery. So I need another piece of something to dispense that. I'm using just a bit of stiff copper wire here as my dispenser. Probably not the best choice, of course. Well, it'd be great if I could actually open this stuff. There we go. For those interested, this is the weapon of choice in this case. This is quite a tacky flux. It's kind of like a paste. You know, you can stab it like this. What I like about this is it will let me, it lets me, what's the word for it? Position. Yes, position. Really difficult word, Damien. It lets me position the package in the right spot, but it just holds it down that little bit for me. And it's really effective flux for drag soldering, which is what we'll be doing here. So I'm just gonna, again, probably not the best applicator because it's trying to run away from me all the time. But we'll get there. Obviously I need to keep this away from our central pad. We don't need any of that there whatsoever. Now, more application of our flux. I'll try and find links to this. I'll definitely put a link to the epoxy in there for you. I'll try and find a link to this flux. I got a couple of jars of it from AliExpress, but I think it's on Amazon and eBay and places like that as well. Now there's a little bit there. There we go. So we got a good application of that flux going around. Get rid of that piece of wire. All right. So now my apologies on this next part, because I'm probably gonna not be able to film this in the best of a way. So I'm going to be positioning our chip on here, and I'm going to be using this kind of a magnifying headset when I'm getting in here. So apologies if this turns into a thing where you're staring at my skull for half the time. So strictly speaking, I should be using a vacuum pickup tool to pick this up and plop it down in the exact right spot. Naturally though, this being a Damien job, we're not going to be doing that. So I'm going to just open up the little cover like so. Just see if we can rid of that. There it is. Now there's a dot here, which is our pin 1 dot, and that's got to go here in this corner. This is our pin 1, where my, well, really, yeah, this is my pin 1 here, where I want to be. So you want the Texas symbol pointing that way. So Texas is south, I guess. Okay, well, who knew? Right, so procedure that I use for this, I know this is going to get some serious cringe. There's a pair of straight tweezers. Just pick the package up out of the thing, and I'm going to get my fancy headset on here. I'm just going to go like that. That's it. Now I'm going to turn this light on this thing, so sorry if this makes a mess out of the filming. So here we go. I'm just going to walk the chip around with my finger a little bit, just to help to settle, hopefully, that epoxy underneath there. It's actually looking really good where it sits right now. So, next step. This gives me, I think, is it like a 5 mag or something? I think it's a 5 mag, excuse me, that provides. I do have one that gives me more magnification, but it's on, it's sitting there. So we can get rid of that. I won't be going back in the thing again, and I'll put my spare fancy epoxy over there out of the way. I always lose this. Yay, here it is. Okay, so I got this little guy. It's got a light on him again, and I'm going to just, really, seriously? Would be when I'm on camera, wouldn't it? Ooh, rumor has it Damien is a complete moron. Alright. Ooh, rumor has it. Yeah, that's looking pretty darn good. It's actually even, yeah, I think it's that's pretty good where it sits, folks. Rumor has it Elon is a crazy person. You know, Elon, life would be so much easier if you didn't do all this code security crap. All right, but then again, I wouldn't get to look like a prat on, I was going to say national TV, but I don't know, international TV, maybe, I don't know. All right, so our chip is sitting there, it's happy as a clam, and this is where that kind of sticky flux comes into play, because it doesn't let it wander on me. So obviously I'm going to make 100% sure at this point that I have my pin 1 dot on the pin 1. Texas is south, and yeah, we're going to solder the periphery on here, and the last part then is we're going to cook this in order to cure the adhesive that's going in there, so stand by. Now, best way to do this is going to be with a technique called drag soldering. Now what we're going to do to start is we're gonna basically, I'm going to press down one more time on here just to be certain that I'm getting everything is down, yeah, solidly. I'm going to do one more check with this thing. Really? Thank you. Moved a tiny little speck on me. That's what I get for being sure about things. Be sure to be sure, as we say in this part of the world. Now, oh yeah, I see the movement there. There we go. You know, that's actually not too bad. I'm probably been a little bit too cautious. We've been a little bit too cautious with it, but I'd rather be, at this point now, I'd rather be too safe with this job. Yeah, that's good. Okay, no more craziness. So I am going to use a little tip, just a pointy tip, just to get the corners tacked. But then we're going to switch to the big mama for the actual drag soldering. So soldering iron on. Obviously for this purpose, I'm going to use standard leaded solder. It is a pretty thin leaded solder. Oh, damn it. My fancy microphone got snarled. Right, so again, apologies if this doesn't come out ideally, because I do have to use the magnifier for this task and get my head in there pretty darn close. This is it, folks. Wish me luck. Okay, nice blob on that one. Nice blob on that one. There we go. Tacked. So, at this point now, I'm going to change out my tip for the big mama. And I'm actually going to go for a heavier gauge of solder. Get a nice bit of wetting on that. Then I'm just going to drag. Like that. Done. Now, Elon has made this one a little bit more tricky, so I'm going to start here in the middle. Do not forsake me, oh my Elon, on this our soldering day, eh? Right. Do not forsake me all night long. Oh, getting a little bit. Oh, not exactly. There we go. There we got him. Beautiful. Do 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 do. And this our soldering day. That's it. Now what we got to do. My hands are shaking. I need to steady this a little bit. It's turning out really well. Now, this little section up here in the corner that we want to get. Do not forsake me. There we go. Now, so at this point, we're going to have most of the legs soldered on. We will have some visible areas where we have solder bridges. So at this stage, our next phase is to use a little bit of this solder wick. This is the stuff that I use that is quite effective. So I'm going to, change back to the smaller tip, trim this down, and we'll go in there and basically mop up any excess and go back to our smaller solder now for the purposes of catching any that we may have missed on the initial drag solder. Now I'm deliberately not editing this or cutting any of this out. You can fast forward as much of this as you please, because I do just want folks to see the whole process as we do it. So at least then, let's make sure you're seeing what I'm seeing. Are you seeing what I'm seeing? Do you see what I see? Yes, you do. Grand. Okay. All right. point here. There it is. Now at this point as well, what I'm going to do is I'm going to apply some of that, actually going to get out a bit more of this flux, nice tacky stuff. This time I'm going to use my brain and maybe use a screwdriver to apply it. There we go, that's a little easier, isn't it? There we are. Key with all these kind of jobs is to do them slowly, kind of pace yourself, and if you're getting frustrated or you're in a hurry or anything like that, just walk away from it. Easier said than done, of course, but I'd say I've learned that lesson the hard way over the years. Just this flux is just amazing. It will literally just make the solder go where you want it to go and not go where you don't want it to go. It's just managed to pull out a big lump here that was somewhere it shouldn't have been. There it is. Absolute thing of beauty. I'm going to put a little of the thin solder on here now. There's a few pads that look a little bit insufficient. There we go, that's got most of them. There we go. Oh yeah, that is gorgeous. Oops, I've managed to blob a pair here. These ones are looking fine now, there's no insufficiencies whatsoever there. I'll trim the braid again. There it is, sorted. All right, on to the next side. So what I will do is I'll stop recording here now, and I'll just go around the other three sides. I'll be doing broadly the same thing, so you're not really going to learn anything from that part. Once we get this done, then I'll come back and we'll be going for the bake-on of the epoxy that we put in the center. Alrighty, so our chip is now on. Got all of our pads soldered, all the solder bridges taken care of. So what I'm going to do next, and keep in mind I am making this up as I go along, I'm going to hit this with a little flux remover just to get rid of a lot of the flux residue here, just because there is a lot of it. I had to use quite a bit for what I was doing here, so I'm going to try and just, don't know if it's effective or not. Might actually just tilt it up here a bit, just give it a little blast off onto the floor. Probably the best way to do it. So, a little bit of rag and just clean off from around our package here as best we can. And the reason for that is our next phase of the operation here is where we want to bake on the epoxy that we put in underneath here. I don't really want that flux going everywhere on me, so I'll give it some IPA here now. Next, same procedure, I guess, is going to be the best way to go. Just let it off on the floor. And a little bit of clean rag and just clean it off. Now we will be doing another inspection and cleaning operation on this guy once we get her baked on, but that should be sufficient now to just to have that flux residue broadly taken care of. Get rid of that. There we go. Alright, now next up we got to bake this guy. Now the way I'm gonna do this is probably gonna be you know, the Damien way versus the proper way. So first thing I'm going to do is take some of this Captain tape that you'll have seen me messing about with here before. And I'm going to cut a few strips of this. There we go. Just to protect the other components on here from any heat splash. You know, it's not perfect, of course, but it's better than nothing. Alright, and go like that. I'm just gonna put that in like so. All right, now if we look at our, where am I gone? If we look at our data sheet for this particular product, it says that the cure time is 2 hours at 65 or 30 minutes at 100. So we're going to go for the 30 minutes at 100 option. Okay, so prepare for a whole spate of "Damien, you're doing it wrong" comments. So what we have is we've our chip on here with our fancy cold solder under it. We've a thermocouple just pushed in under the legs, currently reading just under 18 degrees centigrade. I have my trusty heat gun cable tied to this stand pointing at the chip. So here we go. And we are going to start heating our area here. As you can see, where temperature is coming up, but obviously that won't be the temperature on the center pad as yet. So we're going to wait for that temperature to come up to close enough to 100 degrees, and we're going to start our curing timer then. Going for a gentle heat here, nothing crazy. We're at 100 degrees on the temperature and 75 on the airflow. So once we get our temperature up here, we will be able to start curing, and I'll come back to you then when we are cured, hopefully. Well folks, getting to this stage has been, as tends to be with these things, a proverbial tour de force, and not for the reasons that you may think. We're now executing for the first time our own software on the replaced TMS 320F 28377D microcontroller on the rear drive unit inverter. We have loaded that software in by means of the kind of multicolored wires that you see here going to that horrific little small high-rose JTAG. And you'll see here as well that I've made some modifications to my TI launch pad in order to be able to do that. Now, we just turn that bench light off. You'll be able to see those LEDs doing their thing a little bit easier. Now, we're currently flashing just a little blink program, so very similar to what you do for your first Arduino kind of a thing. We're flashing it at each of the LEDs at 100 Hertz. Now, I understand that some people are probably going to think that that's fake. So I've got my JTAG hooked up in good old Code Composer Studio here. So I'm going to change my delays to 1 second, and we'll go, we want to go build that, CPU 1, RAM M3, hit that. Build finished and debug. So that should load this into RAM if I'm doing this right, which I rarely am. It's doing something. It's a loading program, it says. Okay, and if I execute, there we go. So we're now flashing the LEDs at 1 Hertz. So hopefully I won't have 20 people in the comment section telling me that I'm faking this thing. So why did this take us so long to get to this point, and why didn't I do this in the first place, I hear you cry? Well, let's have a look. Now, as we all know, I'm not particularly smart, and you may recall that during one of the earlier videos that I indeed did connect a JTAG to an unmodified inverter. And I used this stupid thing to communicate, or attempt to communicate with it. Guess what? This don't work. No matter what I did with this thing, it kept informing me that I had a break in my JTAG wiring between the programmer and the target processor. Turned out that this is an FTDI 2232 chip here. Very same device, just in a different package to what they have on the TI Launchpad demo board there. And turns out that this is missing a 1K resistor from one of the pins to ground. So I put that in and it made no difference. So looking at some of the diagrams and stuff for this, I haven't been able to find an actual circuit diagram for this Olimex thing. So if you know where that is, please do let me know. This has some kind of a CPLD, some Xilinx CPLD on the back of it, and God knows what all of that is doing, because turns out to do JTAG emulation on these TI parts, all you actually need is a flippin' FTDI chip, and it's kind of super simple after that. So this has been, I spent a full day trying to get this to work, and just this morning I said, right, okay, forget this. Let's modify our, look at this for camera work. Let's modify our TI Launchpad and just take the JTAG signals from that. And guess what? We connected to our new processor first time, and loading and executing, and I think I could even do some tracing on this. I'm not sure, but I think I can do some basic tracing with it. So that's why we weren't able to communicate with this for the last 2 days. Okay, now doing this on camera for the first time, so that usually means there's no chance of this actually working. What I have here is a front drive unit inverter, completely unmodified, untouched and unmolested. It's running Elon's super sexy code in there, and blinking the LEDs away to its heart's content. Now, I'm going to go to my Code Composer studio here. I'm going to go to my CPU 1, RAM M3. This has got my 1 second blink sketch in it. I'm going to hit that. Build finished, and I'm going to go run debug. And what's going to happen now is the next question. Loading program. Okay, if I hit run, yeah, that just happened. So, from what I, yeah, because this is the first time I've done this here. Now, that I was not expecting. Let me just kill the light here just so you can see those LEDs blinking a lot slower. That's my little 1 second blink routine there running on that. And we have just installed this program into the RAM of CPU 1 on a completely unmodified Model 3 drive unit board. And I have it on good authority that this also worked on a unmodified rear drive unit board, which may mean that I have flushed the last 6 to 12 months down the drain with all the stupid modifications that I was desperately trying to engineer to this card. Now, if this is what I think, then we can potentially program unmodified boards. Now, I'm not 100% sure because this is just obviously the RAM of this chip. In order to fully test that, we would need to program or attempt to program the flash. Now, yeah, that's pretty crazy because if I power cycle the board, it will of course go back to running Elon's code because what we loaded in there was just in the RAM. We didn't attempt to program the flash. And I'm just wondering, is that is that because, yeah, so it's not, that's just weird though, because you would think that with all the code security crap that Elon is usually getting up to. I need to do that again just for fun. So CPU 1 RAM, build finished, run debug. Okay, so if we execute, there we go. Yeah. This is going to be the world's most boring video, I know, sorry. Okay, so, stand by. Let's try, what really shouldn't work. So, C2000, 28377D, XDS100 V2, start. So it's not giving me anything happening here. CPU 1, memory browser, read target device. It should not do this. Or maybe I have to hit it, do I? Oh yeah, that'd help. Reading memory. Seriously? Oh, the LEDs have stopped flashing. Okay, it's just going to read it all zeros. Okay, which does make a bit of sense, but that's definitely different than I was getting previously. Okay, rather unsurprisingly. So how do we download settings? Only load RAM only. Perform blank check. Calculate checksum. What's that going to do? Flash operation. Wow. Okay. Doing something. Security settings. What about this? Okay. Program all zone 1 security settings. Yeah. I think I'll give this a miss for the minute. Wow. I need to understand what all that crap is before we get too carried away. But this is definitely more than I got the last time that I tried doing this. Because the last time that I tried doing this, we absolutely did not get anywhere. CPU 1 halted. Okay, so let's exit out of this. I'm going to do my little blinky sketch thing again. So show you this happening from the computer end of it, and run debug. Load program. Execute. And yeah, we're flashing LEDs over there. So yeah. Okay, so obviously in this case we're just putting our pirate code, as it were, into the RAM of that CPU or MCU. So the question that we need to ask ourselves now is, what happens if we attempt to erase this thing? Now, I know that if I don't do it, the internet will demand it that I try. So the next phase of the operation, I'm going to need the Gomcat's help with this, is we're going to erase the, well, first things first. Let's turn off Code Composer Studio here on the computer. We don't need that for the minute. Let's power cycle the inverter to reload Elon's code. So Elon's code is now executing in there again. So what we're going to do here, so I'm going to try and do this. I'll try recording on the computer as well as here. So hopefully you'll be able to see me screw up in as much detail as possible so that you folks can avoid making the same errors. That's what this is all about. So let me see. If we go CPU 1, erase flash. Erasing flash memory. I think it's doing it. Let's try CPU 2. Erase flash. I think we've blanked it. Okay. If I close out, well, yeah, I can close out of this. Go into Code Composer Studio. CPU 1, flash M3, build that program, build finished, run, debug. Loading program. This usually takes longer to do because we're talking to the flash memory. Loading program. Finished. It takes another little bit of time here at this point. It's ready to go. Execute. Unbelievable. Unbefriggin-leavable. So if I had a proper JTAG programmer, we'd have been a hell of a lot further down the line here with this thing than where we are now. So let's turn off this. Let me just kill the recording on the computer, and if we power cycle this inverter now, it should reload our program from flash. Yep, there it goes. So there you have it. There's no need to take these devices off the board at all. You can just erase them and program in the new open inverter firmware. So folks, there you have it. If I had a brain, I would be dangerous. If I had a decent JTAG programmer, we would have been a lot further down this rabbit hole than we found ourselves presently. So, to sum up, there's no need to remove the microcontroller from your board, at least as yet, because it seems as if our Muskian friends have not disabled JTAG. And although we can't read the program out, we can erase it and inject our own pirate code. At the minute, all of our pirate code does is blink some LEDs, so not exactly exciting. But as I said in the previous video, thanks to somebody that's a lot smarter than me at doing this stuff, we are pretty soon going to have the open inverter firmware running on our Model 3 drive units. So I don't know. I mean, this is where the whole thing about sharing information and stuff tends to grind on my brain a bit, if I'm honest. I mean, yeah, there it is. I mean, I'm looking at it blinking over there, and I'm just not exactly concentrating on the camera, which is what I should be doing, of course, which is why my videos are long, boring, and rambling. So, on another note, not unrelated to this, I have been learning quite a lot about that particular series of TI micros that are on these Model 3 drive units, and they're quite interesting parts. This Code Composer Studio thing, Runs on Linux without any problems, so I'm really happy with that because that's where I kind of do 99% of my work. Yeah, and they are, you can kind of tell from even just a, kind of a first look at the data sheets that they've been tailored for the whole motor control stuff. I am worried about what kind of things Johannes will be able to do with this thing. So whatever you do, don't tell him that we're working on this, okay? Like, shh. So I guess you could say we're back on track with the Model 3 stuff. I'm going to wrap this up here because I got to go get some tea and try to figure out what my next direction of travel is. One thing I am going to say, and I've said it before, but it kind of needs to be said again, is that, if I've seen far with this stuff or with any of this kind of stuff, it's because I've literally stood on the shoulders of giants. I wouldn't be anywhere with any of this stuff without the help that I've received. So I'm not going to name names, but all of you folks know who you are, and you have my deepest thanks. So I'm going to crack on with this. The Gome looks like he needs some food, so I'm going to do that. As always, don't forget to dislike, thumbs down, unsubscribe. Do not share this with anyone. Keep it quiet, bury it. Check the links in the description for Patreon and PayPal in case you wish to financially support these crazy things. But as I say again, probably best not to, because then I just get more of this crap and do more of this kind of work. So, nah, don't do that. Also, will be links in there for Open Inverter Forum, JLC PCB, Dallas EV Repair, and whatever else I can think to put in there. If someone can recommend me a good way to learn how to program those TI micros, that would be most appreciated. But other than that, we'll see you in that next episode. And until then, happy Texas instrumenting.